Okay, we're in section 18 of the notes. Let me click on this. We'll go to section 18. And this is going to be the derivative of inverse functions. Certainly, I want to, again, claim where you studied inverses, and that was at the Math 119 level. Certainly was reinforced in the Math 120 level as well. So in 119, they were introduced. And if you need to go back and review that, I would recommend that you go back and review that section from Math 119. You also did the inverse functions in Math 120. What inverse did? The trigonometric inverses. So you should be well aware what an inverse is and how to find an inverse and how to use an inverse. All right, so we'll go through this. We'll go through the pictures. I want to point out the pictures, to me, are worth 1,000 words. And we want to make sure you understand these pictures are being provided as, certainly with a reason behind it. But the main reason is to get you to understand what you need to do about the inverses. All right, we'll talk about that when we get there. We'll look at an example. We'll certainly go through the example one stage at a time. All right. So next thing up is we'll talk about the trigonometric functions, which are really interested in getting their inverses. And then I'll do a little review of what you did in Math 119 and 120, and we'll get the derivatives here. I want to point out for a lot of students, they just simply say, well, what are they? I don't care where they came from or how you got them. I just need to know what I need to know to get out of the course. And bottom line is, yeah, you can do that. You're not going to get much of an education from just doing that, but you can do it. You could say this is what you need to know. Of course, we'll derive the first three. These over here, not commonly used, but we could derive those as well, but we're not going to do that. And the reason for that is they really weren't discussed at the 120 level. And I think the main reason we're not discussing 120 level is most textbooks avoid them because their invertible regions are not universally agreed upon. For the most part, though, the invertible regions of these guys over here is universally agreed upon. I've not seen any conversation about that not being agreed upon. So, bottom line is I'll go through that. I'll review what you did in Math 120. The notes here are identical to the Math 120 notes, with the sole exception we start talking about derivatives, which was not done in Math 120, but we'll go through that. So we'll go through these separately. I realize for some students, this might appear to be a very long lecture, but we'll eventually get to doing examples. All right, so what I'm going to do is I'm going to do the whiteboard. And my goal here is to try to understand what's being presented to you. That's my goal. I'm hoping your goal is also to try to understand what's being presented to you. So let me get my whiteboard out. And you're looking at it. And what I'm going to claim over here is, certainly we're going to try to encourage you to read, certainly, including reading your textbook. But let me read it to you. It says, assuming f of x is differentiable and one-to-one with inverse f inverse equals g of x, if a belongs to the domain of g and f prime g of a not equals 0, then we have this statement over here. And for a lot of students reading that, they have no idea what's been said. All right, that's fine, by the way. Sometimes I read things I have no idea what's been said. So what I want to do is I want to look at a picture and I want to see if I can understand what they're saying over here. And I'm looking at this picture. This is a concrete example. And what's nice about concrete example, I'm going to say I'm looking at something and I'm going to say I'm looking at a line. I see this line over here, and this is the line y equals x. That's not a big issue for me. I'm going to say the green curve. For sake of argument, I'm not sure what that green curve is, but I'm going to call it f of x. And what do I notice is there's a red curve that's a rotation about the line y equals x. That's the red curve. And that would be the inverse. F inverse, all right? Now, someone says, I learned that. Well, I can't remember where I learned that. That was done in Math 119. You learned about that. Inverses was a rotation on the line y equals x. So what I did, I just rotated f, that green curve, about the line y equals x, and I get the red curve. All right. Now what I notice, I got points over here. And I want to tell you a point I have over here. I have the point 2, comma, and certainly I'm ballparking it. Looks like 2, 1. And then I got a point over here, which again is a rotation about the line y equals x, and that appears to be 1, 2. Well, that's exactly what I remember from Math 119, that x becomes y, y becomes x. I kind of remember that. Then what I noticed, I got other things. I got tangent lines, and I want to point out over here, this is the tangent line tangent, to f at the point 1 comma, I'm sorry, 2 comma 1. And this line over here is the line tangent. I'm sorry, I forgot to say tangent, line tangent. Line tangent after this. Line tangent, I got to red, tangent to f inverse at the point 1, 2. Let me see if I can do the slope of those lines. And they look pretty simple, right? So the slope of the tangent line, let's do the red one first. Let's do m tan here. I'm looking at it, I'm ballparking it. It looks like the slope of that line, and it got a nice scale down. I can read the scale. It looks like m tangent at that point is 2. And what am I noticing over here on this other tangent line? I'm looking at that line. Again, the lines are really nicely drawn. I can read it. And, certainly if you need to blow it up, you can. What I mean by that, you can do something like this. You can't read my numbers. I can read it okay, though. It looks like 1/2. Now, what am I noticing over here? I'm noticing what they said. Something about being reciprocals. And I'm expecting that. Remember back to 119, y becomes x, x becomes y, range becomes domain, domain becomes range. Now what am I seeing? Rise becomes run, and run becomes rise. Let me point out that. This is rise, that's run. This is rise, that's run. That's what we're seeing. That's what this thing is saying over here. Just what we could expect from Math 119. Let's take a look at an example. I'm not going to claim it's going to be easy for you, but what I'd like to do is I would like to review what you did in Math 119. So in Math 119, what your teacher said to do was write down f of x, 1/1 plus x, put its domain down. Its domain is going to be minus infinity up to -1, union 1 to infinity. Its range is going to be, well, what's its range going to be? I guess it's going to be all the numbers but 0. And yep, you did that in Math 119. Did you make mistakes in 119? Certainly did. Now, what I can write down really clearly, by the way, I can write the inverse down, not the function, but its domain and range. And again, I'm just reminding what you did in Math 119. Well, what happens is, if I know the range of f, I know the domain of f inverse. It's the same. Now, what I did over here, range becomes domain. Domain becomes range. It's a rotation. All right, then what did they tell you to do? They told you to find f inverse. The way we're going to do that is they told you to change f of x to y. And again, you may need to go back and review what you learned in Math 119. Change the x and y. Y becomes x, x becomes y. And try to solve for y. Sometimes that was impossible. I think I got it. Y will equal 1/x minus 1. Y is going to be x, 1 minus x. Put this over here. All right, so I think I did what I did in Math 119. That's what you did in Math 119. And then you would get full credit. Provided there's no mistakes, get full credit, and you move on. Now, what I want to do is I want to, find the inverse. I did that. And I want to, I want to compute its derivative. All right. So I'm going to write this over here. I'm going to write down d dx. It's the calculus now. The inverse of, the derivative of f inverse. Well, I think I can do that. What do? Well, I'll write it down for you. F inverse is going to be 1/x minus 1. And I think I can do that derivative, right? What's it going to be? Minus 1/x squared minus, oh, I got it. This is good news. I got it pretty quickly too. So let's go take a look over here. And I'm going to go to the next page. I got it right over there. I got it. Not bad. Let's see what else they did here. I got the F inverse. I did that. I did that. By the way, for a lot of students, it's kind, and I think it's probably overboard complicated for a lot of students. But bottom line is, you could use this. You still need to know the inverse, though. Yeah, it's overly complicated. You still get the same answer, though. All right. All right, let's go to the next section up. And I'm going to claim that this is going to be mostly a review of what you already did in 120. In fact, the notes that follow are the same notes I give my 120 students, the same notes that are posted on my Math 120 sites. Right? Let's go look at it. And what I want to do is I'm going to say I'm going to use the notes to do the calculus. So I'm going to say, I would love to be able to derive this thing here. This here. This here. But I got to be honest with you. At some point, you're going to need to know this without having to derive it. The other three, I'm not going to derive, but they could be derived if you want to do that with an identical method that we're using here. The next page. And what I want to do is I want to look at their picture. They provide a picture over here. And I want to talk about a picture over here is what this picture is. And I'll label it for you. This is the line y equals x. They claim the sine function there, but not the whole function, part of the function. And we'll talk about that. What does the sine function look like? I'm going to say this most likely is the sine function. I'll write this over here. F of x equals the sine of x. And I'm going to say I see something else. I'm seeing this, which looks like a rotation of the sine function about the line y equals x. So I'm going to say this is most likely the inverse function. What's the inverse function called? Well, it could be called this. That's still read as inverse sine, or some people write down arc sine of x. Let's answer the questions now. Picture's kind of understood. Label and directly on the graph. I did that. What's the domain of the sine function? Let's look at it. The sine function starts here and ends here, and this is the invertible region. So the domain of the invertible region, and again, you would need to know Math 120, goes between minus pi over 2 and pi over 2. That's a domain. I'll write that down for you. Now, when I say this sine function, the one that's graphed, not the sine function, the one that's been graphed. What's the range of that? Well, the sine function, if you look at the picture, goes between -1 and 1. Relatively simple. Label directly on the graph the arcsine function. I did. What do they want to know? They want to know its domain. What's its domain? Well, that's fairly simple. It's going to be the range of that sine function. So it's going to be -1 to 1. What's its range going to be? Minus pi over 2 to pi over 2. All right, here's the deal now. What they say is number 7 now. Again, what's before? This is the Math 120 material. Now we're doing the Math 121 material. Where they say to find the derivative of y equals arcsine of x, we note that sine of y equals x and differentiate. Let me put that down for you. By the way, I'm not claiming this is going to be easy for you. What I'm claiming is you should have some understanding of prior knowledge will allow you to do the problem. So I want to tell you what my goal is. My goal is to actually find dy dx. That's my goal. I don't know what it is. Now someone says, you just gave it to us. We could just look it up. No, I want to derive it. So what I'm going to claim over here, what I do know is I know the sine of y is equal to x. And then we're going to do, they say differentiate it. What's the derivative of sine? It's the cosine of y. Chain rule, derivative of y, dy, dx. All right, not so bad, right? And then what do we get? What's the derivative of x? 1. If I thought about it, it would be dx, dx. I'm not going to write that down. So now I know dy, dx. And what's that going to be? 1 over cosine of y. By the way, there's nothing wrong with writing that down. But I want to be honest with you. That's not what's written down in my notes. But this is true though. This derivative over here just turns out to be 1 over cosine of y. So what I want to do is I want to go back over this and I want to see if I can make sense out of how they got the answer in the notes. So let's put this down for you and I'll write it down for you. So I'm going to put down sine of y is equal to x. And what I'm trying to figure out is what's the cosine of y? Sorry about that. My pencil's becoming a little bit erratic. I don't know. I want to find it out. So what I'm going to do over here is I'm going to talk about it. And the way I'm going to do that is I'm going to talk about, what the angle is, y is the angle. And I'm just going to say, I got to figure this out thinking back to what I did in math 120. And the teachers might have said, do a right triangle, but we need to talk about it more in detail. What's the angle y? What's the ratio? Well, sine is going to be x over 1, right? What's the side going to be? Well, Pythagorean theorem says it's 1 minus x squared. All right, now before I go forward, I want to point out, what's the angle y between? Right over here. I hope you realize the cosine between those numbers is non-negative. So I have something really simple over here now. And what's that going to be? 1 over, I'm sorry, not 1 over, root of 1 minus x squared over 1. Let's go back over here. And what's this going to be equal to? 1 over the square root, 1 minus, and again, one of mine, we just did it over here, x squared. So here's the deal. This function has a derivative, this derivative. We don't write this part down though. We write this down. This needs to be remembered at some point. All right, let's go back to the notes. And now we're going to do the next one. And what I'm going to do, I'm going to look at this picture now, and I'm going to label it for you. This is what you did in Math 120. All right, now whether the teacher did the picture at the board, or they made you read a textbook, or they made you memorize it, it should be understood. So what do I get here? I get the line y equals x. I always do that when I get inverses, by the way. The next thing I want to do is I want to put in what I believe is the cosine. And there's a label on this picture. They say there's a region there. That's the cosine. So I'm going to say this curve over here is y equals cosine of x. I want to put the domain down to that blue region though. And what does that look like? It's between 0 and pi. What's its range? It looks like it goes from -1 to 1. Now I want to put the other guy in. And it's this guy over here. Now I know rotations are tough. I find rotations difficult too, by the way. Oh yeah, rotations. What's that the rotation of the cosine curve? What do we call that? It's, by the way, rotation about the line y equals x. We call it the arc cosine or inverse cosine. Let me write this over here. Or arc cosine of x. What's its domain? Well, you know what? It's the range of that guy. So -1 to 1. And you can see that in the picture, by the way. What's its range? And again, you can see this in the picture, 0 to pi. All right. Okay, let me point out what happened over here. All of these questions have been answered by looking at the picture. Every single one. 7 has not been done yet. So what I want to do is I want to read 7. Let me point out what this is. This material here is the Math 120 material. What we're doing now is we're moving forward into Math 121 now. We're doing derivatives. Let's put this down. Let's write it over here. y equals arc cosine of x. My goal is to find out what dy dx is. Now, someone says you gave that to us in the beginning. You look back in the notes, it's there, but I want to derive it. How they say to derive it, note that cosine of y would equal x. Then they say differentiate it, which of cosine is minus sine y dy dx equals 1. So dy dx is going to be minus 1 over sine of y. Let me get my eraser out, erase this, and I'll write it down. It's going to be minus 1 over the sine of y. But I gotta be honest with you, no one writes that down. They may have gotten an intermediate step, but they don't write that down. So what they do now is they kind of relate back to what you did in Math 120. They drew a right triangle, and what they're trying to do is figure out what the sine of y is. I don't know what it is, but I know the cosine of y is equal to x. So what does it mean? The angle is y, the ratio is x over 1. What's the side over here? Just using a right triangle, by the way, it's going to be 1 minus x squared. Now what do I do? Sine of y. Before I do that, though, I got to be really careful about what the y is as an angle. And what's the y as an angle for this invertible region of cosine? It's between 0 and pi, and the sine function is always non-negative. So this is a no-brainer as an answer over here. Not to worry about signs. So put this over here. I'm going to erase this. What's sine of y? Well, it's really simple to write down. What's going to be that opposite to the angle, 1 minus x squared over 1. Let's go back over here. Let's write that down. Minus 1 over the root 1 minus x squared. All right. We don't write this down, though. We write this down. So if y equals arc cosine, its derivative is this. Let's go to the next one. This was a little strange looking. So I'm going to say this says it's tangent, it's inverse. Well, I think you know what I'm going to do. I'll write this down. Y equals x. I'm going to draw the tangent function, which looks like this. This is the invertible region, by the way. So the blue curve here is going to be a region of the tangent function. And you should be well aware of that. The domain of this picture is between minus pi over 2 and pi over 2. Its range is minus infinity to infinity. All right. The other guy is the rotation of that tangent function around the line y equals x, and that would look like this. What are we going to call that guy? We're going to call that the inverse function, which is tan inverse, or if you prefer, arctangent of x. What's its domain and range? Couldn't be easier. Range is going to be the domain of tangent, so minus pi over 2, and its domain is going to be the range of the tangent, which is going to be minus infinity to infinity. By the way, on a claim over here, although not drawn in, there's asymptotic behavior here. Those asymptotes are x equals minus pi over 2, and this asymptote x equals pi over 2, and this one over here is going to be y equals pi over 2, and this asymptote over here is going to be y equals minus pi over 2. So let me tell you what's happened over here. I've actually answered the first 6 questions of this because it relates back to 120. We need to get to 7 though. All right, let me repeat this over here. This here is Math 120. When we go in this direction, we're in Math 121. You can't go to 121 without knowing Math 120. So let's write this down. And what do we get up here? Y equals arc tangent of x. They go on to note to say that tan of y is equal to x. They tell me to differentiate this. What's your tangent? I hope you can remember. It's secant squared y, chain rule, dy dx equals 1. So dy dx would equal 1 over secant squared, which is cosine squared y. So I know it's derivative now. So the derivative dy dx is actually cosine squared y. I can't use that though. And the reason for that is no one does. So what are we going to do? Right triangle again, and we'll discuss it carefully. What do you get over here? Well, I only know one thing. I know the tangent of the angle y is equal to x. So what does it mean? This is the angle y. This will be x. This would be 1. What would this side be equal to? Square root of x squared plus 1. So the next thing I do is, what's the cosine of y? Well, you know what? If I thought about it, the invertible region, you're looking at the angle between minus pi over power 2, and the cosine is always positive. So I don't have to worry about sine of this thing. What's it going to be? 1 over the root of the x squared plus 1. What do they want? They want me to square that. 1 squared is 1. When you square the bottom, what do you get? X squared plus 1. So here's the deal. Y equals arctan of x. Its derivative, dy dx, we have just shown is 1 over x squared plus 1. This is what we gave you in the beginning. All right, let's go to the next page. Oh, there is no next page. What are we ready to do now? Well, I want to point out basically what you need to remember here about inverses, what you learned in Math 120 and in 119, and how to find the derivatives of those 3 arc functions. Right? Super important. Some people say, no, I need to memorize. That's fine too. But we need to move on to what's next? Examples. What are the examples going to be related to? The lecture. Thank you.